Hello, everybody, and welcome to my channel. Today, I will solve several problems, hydraulics and fluid mechanics. I try to solve 5 problems. So let's start with the problem number 1. So the first problem is about evaporation, determining the volume from a reservoir dam, from the reservoir of a dam. We know the area of the dam or of the reservoir is 5 kilometers square. Yeah, so area equals 5 kilometers square. And we know the evaporation rate is 6 millimeter per day. And we want to determine the volume of evaporated water in 10 days, time 10 days. This is a straightforward problem, but we have to take care of the units. So the volume evaporated water in 10 days is, so the volume equals the area multiplied by evaporation rate. Let me write down the volume equals the area multiplied by evaporation rate multiplied by the duration, the time. So we know the area is 5 kilometers square, 5 kilometers square. Then we convert the kilometer square to meter square divided by 1,000 meter per multiply by 1,000. We want to change from kilometer square to meter square. So we multiply by 1,000 meter per kilometer by 1,000 meter per kilometer. So we can here cancel the kilometer square with the kilometer square here. And now we need to multiply by the duration, the time, which is 10 day. 10 day. And also we multiply by the evaporation rate, which is 6 millimeter per day. So we multiply by 6 millimeter, 6 millimeter per day. So the day cancels with the day. It's very important to put in the units so that you know that you are correct from a unit point of view. So we have to convert the millimeter to meter. So we divide by 1,000 millimeter per meter. So we take the millimeter here. So we are left with meter by meter by meter. So that's meter cube. So the volume, if you do the calculation, the math, you will get that the volume is 300,000 meter cube. So this is the volume of water that evaporates in 10 days. This is very straightforward type of problem, but yeah, it occurs in the FE exam. The next problem is about finding a force, determining the force, hydrostatic force on a trapezoidal gate. So let me remove this. So we have a trapezoidal gate. Trapezoidal gate, we have the dimensions of the gate. So the gate is 4 meters, the top width, and 2 meters. This is the gate, and 2 meters. So this is 4 meters. The top width is 4 meters. And this is 2 meters. And the height of the gate is 3 meters. This is a 3 meter. And the gate is 2 meters below the water surface. The top of the gate, this is a 3 meter. If this is the water surface, so the top of the gate is 2 meters. The gate is vertical. So the gate stands vertical like this. And it is 2 meters. The top of the gate is 2 meters from the water surface. This is 2 meters. And this is the height of the gate, which is a 3 meter. So when we know this information and we want to determine the hydrostatic force on the gate, determine the hydrostatic force on the gate. So we know that the easiest way to calculate the hydrostatic force is by this formula, F equals P dash multiplied by the area of the gate. Now what's P dash? So P is the pressure at the geometric centroid, at the centroid of the gate. So this is P. So we want to find the average pressure at the Y bar of the gate. So we need to determine the Y bar of the Y bar of the gate first. Then we can easily determine the area. Then we multiply the area by the pressure, and we will get the force. So this is the gate. Gate is trapezoidal. So we want to find the Y bar of the gate. I will assume that the 0 is here. So Y equals 0. Y equals 0. Actually, Y equals 0 is at the water surface. Okay. But for the gate, okay, Y equals 0 at the top of the gate. So I want to find the Y bar. Now, either you can do the calculations to determine Y bar of the gate, or you can have a formula to determine the Y bar for a trapezoidal shape. But it's easy to determine the Y bar for this shape. So the Y bar is sigma. You remove this. So Y bar equals sigma AI YI Y bar I divided by sigma AI. So here we have 3 areas. Here we have 3 areas. We have one which is a triangle, and we have 2 which is a rectangle, and we have 3 which is also a triangle. So A1 equals, so this is 4, this is 2, so this is 1. this distance is 1, and this distance is 1. So it's 1 by 3 divided by 2, which equals 1.5. So A1, A2 also equals 1.5 meters square. Okay, A1 equals A2, A3, sorry, A3. In A2 equals, it's a rectangle, so it is 2 by 3, which equals 6 meters square. Now we want to find the Y bar for each of the sub areas. So Y bar 1 or Y1 bar equals so the Y bar is taken from the top of the gate. So we know the Y bar for the triangle is 1/3 of the depth here. So the Y bar is for the triangle for A1 is 1. This is a 3. So it is 1/3. So it is 1. And it equals Y bar 3. Now Y bar 2 is, it is a rectangle. So Y bar 2 equals 1.5, 3 over 2 at the center. So sigma. So Y bar for the gate equals A1 is 1.5 by 1 plus 1.5 by 1. So this is by 2 for the 2 by 2 for the 2 triangles plus the rectangle, which is 6 by 1.5 divided by the area. The total area is 9, which is 1.5 plus 1.53 plus 6. This is 9. So this gives us Y bar equals 1.33. 1.33 meter from the top of the gate. So now we can find the pressure at Y bar. The pressure equals, now the gate, we have to find now the H. Now H for the pressure, now pressure equals rho GH. Pressure equals rho GH, rho GH. Now we know rho and G, so we want to determine H from the top of the water surface. So H equals from here. Now the Y bar is 1.33 from the top of the gate. So Y bar is, so H is 2 plus 1.33. So that's 3.33. So that's H. So now we have P equals rho GH. So F equals P multiplied by the area, which is rho GH multiplied by the area, which is rho is 1,000 for the water, by G is 9.8. 1 by H is 3.33 multiplied by the area, which is 9. Now, if you do the calculations, you will get that F equals 294 kilonewton, 294,006 Newton, which equals 294 kilonewton. So this is the solution. This is very common type of problem in the FE exam. Maybe for this type of problem, it is better to have the formula for the centroid of the trapezoidal if the shape of the gate, for example, is not a rectangle. If it is difficult to, or if it takes time, it is not really difficult, but it takes time to calculate the Y bar, it's better to have the formula for the centroid. So let's have one more question. Okay, this is a head loss example in pipe. So we have a pipe of known length, which is 100 meter. We have the length of the pipe is 100 meter, and we know the diameter, 0.2 meter, and we know the flow rate, 0.04 meter cube per second, and we know the Darcy-Weisbach friction coefficient, and we want to determine the head loss. So there is a formula for the head loss, which is head loss equals F head loss if L over D V square over 2G. This is the Darcy-Weisbach head loss formula. Head loss equals F L over D V square over 2G. Now for this type of formula, this is an easy formula. So it's easy, or it's better to remember this formula rather than to start looking for it in the handout you have. So some formula, it's better to also remember to save time in the exam. So we simply apply, we know the friction, we know the length, we know the diameter, so we can determine the velocity. So velocity equals Q over A. We know the flow, which is 0.04. So A equals by D square over 4. So area equals by the diameter. Diameter is 0.2 square over 4. So the area equals 0.031 meter square, 0.031 meter square. So we can now substitute in the formula. So head loss equals the friction factor, which is 0.2. We want to find the velocity. So V equals 16. We know the flow. So the flow is 0.04 meter cube per second. So V equals 0.04 multiplied by the area 0.031, and that gives us V equals 1.29 meter per second, 1.29 meter per second. So now we can substitute in the formula and find the head loss. So let's substitute here. So head loss equals F, which is 0.02 by L, which is 100 meter, by FL over D, which is D is 0.2 v square. So v is 1.29 by 1.29 over 2g, 2 by 9.81. So head loss equals, if you do the calculation, you will get head loss equals 0.85 meter. So this is the solution. Again, this is straightforward the problem. You only need to apply the Darcy-Weisbach head loss formula, and you always should be careful about the units. So, okay, let me see. There is another one open channel quick example or quick problem. This one, this is an easy problem, easy open channel problem. So we have an open channel, rectangular cross section. We have the area. We know the dimension of the cross section, 4 by 2. The flow is 16 meter cube per second, and we want to find the velocity. So in this type of problem, if we know the flow, we know the cross section, we simply apply V equals Q over A. That's it. We know the flow, and area is, we know the cross section, that's 2 by 4, which equals 8 meters square. So V equals, we have 16 meter cube per second divided by 8. So it equals 2 meter per second. So this is the solution. This is an easy type of problem, but yeah, there can be some easy problems in the FE exam. So the answer is A. So that's all for today's video. If you have any question about any of the problems solved in this video, please leave me a comment. If you have any question you want me to address, please leave me a comment and I will address in the next videos. Thank you for following my channel, and I look forward to seeing you in the next videos.